Okay, so we know that we're cooling at the dry adiabatic rate, lifting condensation level. Moist adiabatic rate continues to rise, but not as quickly because we're getting condensation because of cloud formation. Now we want to figure out what's our temperature up here at the summit. And there is another equation that we use to calculate our change in temperature. So we have this cool little symbol. It's the delta, the little triangle. It means change. So the change in temperature is equal to the rate, and this time it's asking for, is it the dry adiabatic rate or the moist adiabatic rate, times my change in elevation. So that dry adiabatic rate, we remember that it's plus or minus 10 degrees Celsius for every 1,000 meters. My moist adiabatic rate is negative 6 degrees Celsius per 1,000 meters. And now I need to figure out my change in temp. Good. So my change in elevation, I can get that guy figured out. So I'm starting here at 800 meters and I'm going up to 4,000 meters. Okay. So it's going to be the moist adiabatic rate. So in this case, we're going to have our rate is equal to negative 6 degrees Celsius for every 1,000 meters that it goes up. And I'm going to multiply that times my change in elevation. I started at 8, I go to 4. That's going to give me 3,200 meters all over 1. The next step that I always try to do is to cancel if I can. And I can. I see meters here and I see meters here. So I'm going to go on the bottom and on the top. I can get rid of those. I've got 3,200 and I've got 1,000 down here. Now, I see those two zeros on the end. Basically, it's 32 times 100 and 10 times 100. If I divide both of those by 100, then I can get rid of those last zeros and those last zeros. And that makes me happy. So what do I end up with when I drop all of that down? I'm going to end up with negative 6 degrees Celsius times 32, nothing else, all divided by 10. That's going to give me negative 192 degrees Celsius all over 10, or it's going to give me my change in temperature equal to negative 19.2 degrees Celsius, because I divide by 10 and divide by 10 to bring that over. Okay, so what does that give me? Well, I knew that in Sacramento, at 0 meters, my temperature was 15 degrees Celsius. I knew that at the lifting condensation level, that was at 800 meters, that my temperature was equal to 7 degrees Celsius. And now I've got this change in temperature. So we're going to do a little change in temp from my lifting condensation level up to my summit. That change in temperature is negative 19.2 degrees Celsius. And so my new temperature up at the summit at 4,000 meters is 7 minus 19, which gives me negative 12.2 degrees Celsius. Okay, so what do we got? Temperature is negative 12.2 degrees Celsius. As that air parcel was rising and rising and rising, it was getting colder and colder and colder. Now we know that as temperature goes down, relative humidity goes up. We saw that over here, relative humidity reached 100%. It's going to stay at 100% all the way until it reaches that summit. So at the very summit, relative humidity will continue to be equal to 100%. Now, something happens, though, as our air parcel starts down that leeward side. Let me put that in windward, leeward. On that leeward side, the air parcel is going down. So the parcel sinks. Because the parcel is sinking, the temperature is going up because of compression. And because the temperature goes up, relative humidity goes down. So it's going to be less than 100%. And we know that when relative humidity is less than 100%, we are going to have a rate of change, but now we're to the dry adiabatic rate. It's going down, so temperature is increasing, and all the way from the summit all the way down to Reno, it's going to be increasing by the dry adiabatic rate by positive 10 degrees Celsius for every 1,000 meters that it starts to come back down. Okay, well, we can figure out what the temperature is down here. We know that as soon as it started to come down the hill, that relative humidity became less than 100%, so we're just going to go less than 100%. But what's our temperature over here in Reno? Voila! Let's come back to this guy. Okay. So we're going to be using some different numbers this time. This time it's going to be the dry adiabatic rate, and that dry adiabatic rate will be positive 10 degrees Celsius for every 1,000 meters. That's my rate. My change in elevation, I'm going to be going from 4,000 down to 1,500, and so that's going to be 2,500 meters, and so that's going to be 2,500 meters. Because I'm multiplying and I'm multiplying fractions, I just always like to put that guy over 1 because fractions to fractions. And then Crozier's next step is to get rid of our units and reduce as much as we can. So I've got meters over meters, and so I can get rid of those. And I've got 25 times 100 and 10 times 100. So I'm going to get rid of those last two zeros and those last two zeros. This is fun. Okay, then I've got 10 over 10, so I can do that guy as well. So now what do I end up with? I end up with positive 1 degrees Celsius times 25 all over 1. 1 times 1 equals 1. And so my change in temperature is equal to positive 25 degrees Celsius. So at the summit, I was at 4,000 meters. I'm sorry, at 4,000 meters, I was at negative 12.2 degrees. Now my change in temp is equal to positive 25 degrees Celsius. And so the Reno temperature at 1,500 meters is going to be equal to 12.8 degrees Celsius. So let's come back over to our chart. 12.8 degrees Celsius. Now, we began to rise at the dry adiabatic rate. We reached the lifting condensation level. We cooled at the moist adiabatic rate. Then as we descended back down, the whole trip was at the dry adiabatic rate. Dar, mar, dar.